Okay, so what we're going to do is we're going to do some practice half-life problems. And while we're doing that, I'm going to explain how so the sample question is the half-life of plutonium-239, so Pu-239 has a half-life equal to 24,300 years. If a nuclear bomb released 8 kilograms, so that would be our M sub O, 8 kilograms of this isotope, how many years would pass before the amount was reduced to 0 kilograms, to 1 kilogram? So here's the problem. All right. Half-life is 24,300 years. If a nuclear bomb released 8 kilograms of this isotope, how many years would pass? How many years would pass before the amount reduced to 1 kilogram? Okay, so we're going to start our half-lives. Into our time, which is going to be in years. We're going to start with our original mass, which is in kilograms. And this is going to be what is remaining. And that's really all we need for this problem, what is remaining, because they're asking for what would be the time at 1 kilogram. So we're starting with 0 half-life, 0 time has passed, and the starting mass is 8 kilograms. After 1 half-life, 24,300 years have passed, and 4 kilograms are left. So we're trying to get to 1 kilogram. So we could even do this ahead of time. After 2 half-lives, there are 2 kilograms left. And then after 3 half-lives, there is 1 kilogram. And that's where we wanted to end up. So each half-life, half of the sample decays. So 8 to 4, 4 to 2, 2 to 1. So half of sample decays. Okay, so now we're going to 2 half-lives, 3 half-lives. We need to find out how much time has passed when we get to this point. So after 2 half-lives, 24,300 times 2 is 48,600 years have passed. And then in one more half-life, we can add another 24,300 to that. So 72,900. That's how many years have passed after 3 half-lives. That's how you do that. Okay, let's look at the next sample. So the next sample life is the half-life of radon-222 is 3.8 years. How much of a 100-gram sample will be left? So this is basically the same type of a problem. We have 15.2 days. So let's start with half-lives. Time that has passed, and this is going to be in days. Sample remaining, so this is going to be the mass in grams, and this is the mass that has decayed. All right, so 0 half-lives, 0 time has passed. We're going to start with a 100-gram sample, and no mass has decayed. after one half-life, 3.8 days have passed because the half-life is 3.8 days. The mass of 100 grams has dropped down by half, so that's 50. And then the mass that has decayed is 50. And the reason is because 50 plus 50 equals 100, our original sample. Next, at 2 half-lives, 3.8 plus 3.8 is 7.6 days have passed. The mass has now dropped from 50 to 25. And our time has gone from, our mass that has decayed now has decayed 25 more, so that's 75. Next, 3 half-lives, so let's look. 7.6 plus 3.8 goes to 11.4. 11.4, 12.5 is left, so this is going to be 87.5. And then 4 half-lives, half of adding 3.8, and that's going to bring us to our 15.2. 15.5. So it's not quite exact, but it's pretty close. Divide this in half, 6.25, and that's going to bring us to 87.5 plus 6.25, and we'll round off 93.7. So 93.7. Oh, how much will be left is 6.25. That's how much will be left. 93.7. I know that this is a little bit more, but don't forget we have a mathematical equation which calculates this out perfectly for us. So for those of you who are using the mathematical equation, you would get exactly 15.5. Number 6. The half-life of cobalt-60 is 5.26 years. If there are 50 grams left after 15.78 years, how many grams was the original sample? Okay, so the half-life is 5.26 years. We're going to use the same process here, half-life, time, in years, 0, 0. But what we're looking for is the original sample, that. Okay, so mass of the original sample in grams. 5.26 years, 1. We don't know how much has decayed because we don't know what we started with. We don't know. So after 2 half-lives, 10.52 has decayed, time has passed. After 3 half-lives, 15.78. So we're where we want to be right now after 3 half-lives. See? If 50 grams are left after 15.78. So we put our 50 grams here because that's how much they said was left. Now we're going to work backwards. We're going to double. Doubling to 100. Doubling to 200. And then doubling one more time to 400. Okay, so that brings us to 400. So the answer is, how many grams were in the original sample? 400 grams were in the original sample. After 1 half-life, 200 grams were remaining, then 100, and then 50 at 15 minutes and 15.78 years. Okay, the last example is going to be with gold 198, which is going to decay. 100 grams is going to decay to 6.25 grams in 10.8 days. What is half-life? So we have half-life, which is 0 at the start. Same chart, time in days, which is 0 at the start, and then mass remaining, which is going to be in grams, and we start at 100 because it says right here 100 grams decays to 6.25. So now what we can do is we can actually decay the mass down to 6.25. So that would be 50, and then 25, and then 12.5, and then 6.25. And that tells us how many half-lives. 1, 2, 3, 4 half-lives. And at 4 half-lives, 10.8 days have passed. Now, to find the half-life equals 10.8 days divided by 4. So I take my calculator and I do 10.8 divided by 4, and that equals 2.7. So that would be 2.7. So after 1 half-life, 2.7 days. After the second is 5.4 days. After the third is 8.1 days. And then the fourth will bring us to 10.8 days. So that's how you do 4 different types of half-life problems. Okay?